The Kariba Dam, Zimbabwe and Zambia. The Kariba Dam sits on the Zambezi River on the border between Zimbabwe and Zambia and created what was, at the time of its completion in 1959, the largest artificial lake by volume anywhere on Earth. A body of water so vast that it took years to fill completely and permanently altered the regional climate, rainfall patterns, and ecosystem of an enormous stretch of Central Africa. The dam itself is an arch dam, meaning it uses the curved shape of its structure to transfer the enormous pressure of the water behind it into the walls of the gorge rather than relying entirely on the mass of the structure itself. A design choice that allows it to be relatively slender compared to the force it holds back. What makes Kariba genuinely strange rather than simply large is the combination of engineering ambition and human consequence that accompanied its construction. The flooding of the Kariba Gorge displaced tens of thousands of the Tonga people from land their communities had occupied for generations, relocating them to areas that proved far less capable of supporting the agricultural life they had previously sustained. The dam also sits on a geological fault line that has produced thousands of small earthquakes since the reservoir filled, a phenomenon known as reservoir-induced seismicity that Kariba helped bring to scientific attention as one of the earliest and most studied examples of a large reservoir changing the seismic behavior of the crust beneath it. Engineers have identified structural concerns about the dam's plunge pool. The area at the base where water discharged through the spillways has eroded the rock over decades, raising questions about long-term stability that have made Kariba one of the most discussed cases in dam safety literature globally. The Three Gorges Dam, China. The Three Gorges Dam on the Yangtze River in China is the largest hydroelectric power station ever built by total generating capacity, a structure so massive in its physical dimensions and so significant in its consequences that it shifted the distribution of the Earth's mass enough to measurably slow the planet's rotation by a fraction of a microsecond. An effect so small it has no practical consequence, but so conceptually striking that it regularly appears in discussions of what human engineering has become capable of achieving. The reservoir created behind it stretches for over 600 kilometers upstream, and filling it required the relocation of more than 1 million people from towns, villages, and cities that were submerged as the water rose, one of the largest forced relocations associated with a single infrastructure project in recorded history. What makes Three Gorges genuinely strange beyond its scale is the range of unintended consequences its construction produced. The reduced sediment flow downstream changed the character of the river and affected agricultural land that had relied on annual flooding to replenish its fertility. The weight of the reservoir water is believed to have influenced local seismic activity, and the submersion of an enormous stretch of the Yangtze River Valley permanently erased archaeological sites and cultural landscapes that had existed for thousands of years. The dam generates electricity for a significant portion of China's population, while simultaneously representing one of the most complete examples available of how a single engineering project can reshape the physical, ecological, and human geography of an entire region in ways that extend far beyond what any initial planning process fully anticipated. The Contra Dam, Switzerland. The Contra Dam in the canton of Ticino in southern Switzerland is an arch dam that reaches a height of approximately 220 meters above the valley floor, making it one of the tallest dams in Europe, and it occupies a position in popular culture that most dams never achieve. It appeared in a James Bond film, used as the location for a scene involving a bungee jump from the crest that became one of the most recognized opening sequences in the franchise's history. The dam is a double curvature arch design, meaning it curves both horizontally and vertically to distribute the pressure of the water behind it into the surrounding rock with maximum efficiency. And the engineering elegance of that form is visible from the valley below in a way that makes the structure genuinely striking as an object independent of its function. What makes Contra genuinely unusual among large dams is the recreational use that has developed around its extreme height. The dam hosts regular bungee jumping operations from its crest, making it one of the highest bungee jumping locations in the world and one of the very few pieces of critical water infrastructure that doubles as an extreme sports venue. The combination of a functioning dam holding back a significant reservoir and a commercial operation sending paying customers off its edge on, Elastic Chords represents a specific juxtaposition of industrial, seriousness, and recreational spectacle that is genuinely difficult to find anywhere else in the world's infrastructure. The Vajont Dam, Italy. The Vajont Dam in northeastern Italy is not the strangest dam on this list because of what it was designed to do, but because of what happened to it in 1963. An event that removed it from the category of engineering achievement and placed it permanently in the category of catastrophic failure, despite the dam itself never actually breaking. The structure, a thin arch dam that was among the tallest in the world at the time of its completion, remained structurally intact throughout the disaster that made it notorious. What failed was not the concrete but the understanding of the geology surrounding the reservoir. A massive section of Monte Toc, the mountain overlooking the reservoir, had been showing signs of instability since the reservoir began filling, and on the night of October 9, 1963, approximately 270 million cubic meters of rock and earth slid into the reservoir at speed, displacing the water in a wave that overtopped the dam by approximately 250 meters and destroyed the town of Longarone and several surrounding villages in the valley below, killing nearly 2,000 people. The dam still stands, holding back an empty reservoir in a valley that was never rebuilt or reoccupied in the same way. A functioning structure presiding over a permanently altered landscape where the consequences of what was not understood about the surrounding geology remain visible in the shape of the hillside that moved and the absence of the community that the wave erased. The Hoover Dam, United States. The Hoover Dam on the Colorado River between Nevada and Arizona was completed in 1936 during the Great Depression and represented at the time the largest concrete structure ever built. An achievement accomplished under conditions of extraordinary pressure, both the political pressure of a government desperate to demonstrate that large-scale public works could transform the economy, and the physical pressure of a river whose management had defined the development of the American Southwest for decades. The dam is an arch-gravity design, using both its curved shape and its sheer mass to resist the pressure of Lake Mead behind it. And the geometry of the structure, combined with the Art Deco styling applied to its visible surfaces, gives it a visual character unusual among large dams, which tend toward a purely functional appearance. What makes Hoover genuinely strange is the relationship it has developed with the ground beneath it. The weight of the water in Lake Mead has depressed the Earth's crust in the surrounding area by measurable amounts, and the fluctuation of the lake level as the reservoir fills and empties with drought and precipitation cycles produces ongoing changes in that depression, making the geology beneath one of America's most visited landmarks a living record of water availability across decades. The dam also sits in a seismically active region, and the reservoir has been associated with increased local earthquake frequency, placing it alongside Kariba as an early and well-documented example of the seismic consequences that large reservoirs can produce in susceptible geological settings. The Itaipu Dam, Brazil and Paraguay. The Itaipu Dam on the Parana River on the border between Brazil and Paraguay held the record for the world's largest hydroelectric power station by annual energy generation for a period that lasted until Three Gorges surpassed it. And it remains significant not only for its generating capacity, but for the political and logistical complexity of building and operating a major piece of infrastructure that belongs jointly to two sovereign nations with different languages, different electrical systems, and different energy needs. The dam supplies a remarkable proportion of Paraguay's entire electricity consumption, while simultaneously providing a significant share of Brazil's, meaning a single structure on a single river simultaneously defines the energy economy of one country and makes a major contribution to the energy economy of a country many times larger. What makes Itaipu strange in a structural sense is the variety of dam types used in its construction. The main dam combines different structural approaches across its length, including hollow gravity sections, buttress sections, and earthfill embankments, creating what is effectively several different types of dam joined together into a single continuous structure rather than one uniform design. Applied across the full width of the river, the construction required diverting the Parana River, one of the largest rivers in South America, through a channel cut specifically for that purpose. A preliminary engineering project that was itself comparable in scale to many of the largest infrastructure projects built independently elsewhere in the world. The Gordon Dam, Australia. The Gordon Dam in the wilderness of southwestern Tasmania in Australia is a double curvature arch dam that holds back Lake Gordon, the largest reservoir in Australia by volume, in a region so remote and so environmentally significant that its construction in the 1970s triggered one of the earliest and most consequential environmental campaigns. A campaign that galvanized public opinion around wilderness preservation in a way that transformed Australian environmental politics. The Gordon Dam therefore exists simultaneously as a functioning piece of infrastructure and as the event that created the conditions for its own sequel to be stopped, making it one of the few dams in the world whose most significant consequence was a dam that was never built. The Tarbela Dam, Pakistan. The Tarbela Dam on the Indus River in Pakistan is the largest earth-filled dam in the world by the volume of material used in its construction, a structure built not from concrete, but from compacted earth and rock fill on a scale that required moving more material than any other dam project in history up to the point of its completion in 1976. The dam holds back the Tarbela Reservoir in the Khyber Pakhtunkhwa region, serving the dual purpose of hydroelectric generation and irrigation water supply for agricultural land downstream that depends on the controlled release of Indus water for its productivity. What makes Tarbela genuinely strange among large dams is the problem that has defined its operational life since the reservoir first filled the Indus carries one of the highest sediment loads of any major river in the world. And that sediment has been accumulating in the reservoir at a rate that has progressively reduced its storage capacity over the decades since completion, turning the long-term management of sediment accumulation into one of the central engineering challenges of keeping the dam functional. The structure that was built to last has been in a continuous race against the river it impounds, with the sediment carried by that river slowly and consistently working to undo the storage capacity that the dam was built to create, making Tarbela a living example of how the natural behavior of a river system does not simply pause when a dam is placed across it, but continues operating according to its own logic within whatever new configuration human engineering imposes.